This problem states that a runner increases her speed from 14 feet per second to 24 feet per second over 95 feet. Determine the magnitude of the acceleration 2 seconds after she begins to increase speed. And it also tells us that she does this on an outdoor track that has a diameter of 420 feet. Well, we know that since this is a curved surface and she's not running in a straight line, she's running over a curve, she's going to have her acceleration is going to have a tangential component, and this is the derivative of velocity with respect to time, and it's going to have a normal component, and the normal component is a velocity squared over a radius of curvature. And we can figure out the radius of curvature because it's just the radius, and it's 420 feet divided by 2. It's the radius. So this will be 210 feet. And determine the magnitude of her acceleration 2 seconds after she begins to increase speed. So the first thing we need to do, we need to figure out what both of these components are. So what is her regular acceleration? Well, we can figure that out, or her tangential acceleration. And we can figure that out by looking at a kinematic equation. A final velocity is equal to an initial velocity squared. Both these are squared. Plus 2 times the acceleration of a change in position, so delta x. And we know all of these unknowns. We know a final velocity, an initial velocity, and a delta x. We know that the final velocity is 24 feet per second. The initial velocity is 14 feet per second. We don't know what our tangential acceleration is, and we know the change in x is 95 feet. So we can solve for a sub t, and we can get a tangential acceleration is 2.02 feet per second squared. So that is this part right here. Now, we need to figure out this acceleration, our normal acceleration. And to do this, we need to figure out what her velocity is 2 seconds after she begins to increase her speed. So her velocity 2 seconds after she begins to increase her speed is going to be equal to an initial velocity plus whatever his acceleration is times time. And we know everything except the final velocity. We know she has an initial velocity of 14 feet per second. She has an acceleration of 2.02 feet per second squared, and has a time of 2 seconds. So if we perform this calculation, we're going to get 18.04 feet per second. So at 2 seconds, this is how fast she is moving. So if we plug this into our normal acceleration, we get our normal acceleration is equal to 18.04 squared divided by our radius of curvature, which is 210 feet. And we get an answer of 1.55 feet per second squared. Now, we know our tangential acceleration, we know our normal acceleration, so the total acceleration, the magnitude of the acceleration, is going to be equal to the square root of our normal acceleration plus squared plus the norm root plus the square of our tangential acceleration. So if we plug in the numbers we just found, our normal acceleration is 1.55, and we square that, plus our tangential acceleration, which is 2.02 squared, and we get a magnitude of 2.54 feet per second squared. And this is our answer.